So, welcome to this live stream and supercut of a step-by-step beginner's guide to 3D printing. And we're going to be going through the entire process from beginning to end. We're going to go into talking about 3D printers, and we're going to be talking about the different manufacturers, the different types. We're looking at different materials that we could potentially use, and we're going to try and demystify the whole process, culminating at the end of the stream, actually having a 3D print completed. So, who am I? My name is Steve, and this is the IQ Workshop, and this is where I come to share my passion for digital creation, and I try to inspire would-be makers who think they don't necessarily have enough time, money, or space to actually say, you do have these things, and we can, with a bit of persistence and a bit of creative thinking, get this over the finishing line and get you up and running. So what qualifies me to talk about 3D printing? Well, about 10 years ago now, I got started with 3D printing for the first time. I was on YouTube and I saw a bunch of creators, Barnacles and the 3D printing nerd. I saw them making some awesome stuff, and I decided I wanted to follow in their footsteps. The challenge for me, however, was I couldn't afford a 3D printer at the time. So I did what any good maker would do, and that is to educate myself on how these machines worked. And I built my first 3D printer from scratch. And that 3D printer, for some reason, I thought a Delta printer was a really good idea. Why I thought that, I don't know. And we'll go into what a Delta printer is in a moment. But I did a lot of research, and I bought a bunch of individual components from multiple different suppliers around the world. Then I put together my first 3D printer, and I named him. I named him Frank. Frank, the cobbled together Frankenstein 3D printer. So, as I say, Frank was a Delta printer. There's different types of 3D printers that you can have today. There's a lot more variety of machines available to you than there was when I started back in about 10 years ago. And essentially, there's two main sort of routes that you can take as a hobbyist in terms of the types of machines you're going to get. And inside those those categories of printers, there's subcategories. So this stuff can get really complicated really fast. So I'm going to try and keep this as high level and simplified as possible. And as always, these live streams, and if you're watching on the VOD, these are all interactive sessions. So if you have any questions as I'm going through my explanations, or if you want to ask a question in the comments, feel free. I will do my very best to get to every single comment. Not always successful, but I will do my damnedest to do that. But yeah, there's two main types of 3D printers in terms of the technology that you will see in the marketplace. The two types are filament-based 3D printers, or FDM, or resin-based printers, or SLA, or SLM. The filament-based printers, they take a spool of filament, just like this, and it literally is a coil of a plastic filament that gets fed into the machine, and the machine will melt it down and create your 3D object. The other type of 3D printer is one that's behind me, this machine just here, this white machine. This is a resin-based machine, and essentially this uses a liquid polymer that you pour into a vat, and you expose it with a UV light, and that generates the layers of your 3D model. So we're going to be talking specifically about FDM printing, and the printer of choice that I'm going to be talking about is my CR10, my CR10 from Creality. Let me just get this camera kind of pointing in the right direction. I thought I had done, but I've obviously knocked it. But this is a CR10 V2. It is, as you can see, a filament-based printer, and we've got a spool of filament just above me here, and then it feeds into the machine and down what's called a Bowden tube. Now, the Bowden tube is this little blue tube here, and allows us to pass our filament from a distance down to the print head. And the alternative to this would be a direct drive, where the extruder, the actual motor that pushes the filament, is actually mounted on top of the hot end, the bit that gets hot, hence its name. It's mounted just here, and there's pros and cons to having a direct drive versus a Bowden setup. A Bowden machine means that you can put the heavy components that push the plastic through the printer away, and it's not trying to throw that backwards and forwards as it tries to generate your physical object. And that has the positive effect that the machine potentially can print faster. Because there's less weight, there's less mass in the hot end itself. So the alternative is a direct drive machine where that motor and extruder is mounted to the hot end. So the negative is that that slows down the machine because it's got that much more mass, but it gives you more finer control over how the filament gets pushed through the machine. And that can be quite important when printing certain types of machines, specifically flexible materials. Flexible materials don't typically like to get pushed down a long tube and stay, straight. So a direct drive machine can be an advantage when using flexibles. So coming back to Frank and the printer that I built about 10 years ago. So Frank is a Delta printer, and what that means is that the hot end is mounted in this object you see here called an end effector, and there are a series of arms in a vertical configuration. Each of these vertical pillars, essentially the X, the Y, and the Z axis. And with a Delta printer, there's calculations that take place that allow the machine to choreograph these three axes to create a motion in a 2D plane. And then with all three of them combined, they can then give you your Z axes. So Frank was, as I say, cobbled together out of a bunch of, parts that I found. It was Frank used a Ramps 1.4 8-bit controller, as you see here in the picture, and I've got some video footage of Frank actually working. This is the first movements Frank ever made, and it was a slow process. It was a steep learning curve, but it was very rewarding in the sense that it gave me the knowledge and experience to take my maker journey on to the next level. And subsequently, I've been able to work on laser cutting machines, CNC machines, all because of the knowledge and experience that I gained through building Frank from scratch. Now, a Delta printer, if anyone's ever used a Delta printer or calibrated a Delta printer, oh my word, that is, well, you can end up chasing ghosts in the machine, especially on a machine that you've scratched, built from the very beginning and not had much sort of experience with. So it did come to a point where Frank had to be decommissioned, unfortunately. He was decommissioned because I needed a tool, not a learning platform. And that was when I purchased my first 3D printer, which was the CR10 V1. So building Frank, I used a creative method of using a 3D model to draw the objects that I needed for the components that I didn't have, such as the elements that held the hot end, the extruder, and all of that sort of good stuff. So here what we're seeing is a video of the end effector drawing on a piece of paper. And I used this method to draw on a piece of plywood to then build the end effector holder, which you see just up here, holding the pen. But equally, it goes on to build the extruder. So this is my first extruder. It was drawn on a piece of plywood. It was cut using a jigsaw of all things, and then using a pair of grips, it was held together long enough. It worked long enough for me to actually be able to 3D print its successor. I think it managed maybe 3 prints before it failed completely. But that was enough. That was enough to get me by and create the extruder, which, again, wasn't particularly great. It had its flaws, but we then used this version to print a better one. And each iteration of this proved to improve the quality of the machine. So there's Frank in all his glory, working with a Bowden setup, the extruder up here at the top. I've got fond memories and nightmares at the same time of using and building Frank. But as I say, it was a journey that was a wealth of knowledge and experience. So we've talked very briefly about the types of 3D printers. We're going to be looking at SDM printing, as I mentioned. And I am going to just quickly go through, let's have a look. First and foremost, printer setup. So when you get your 3D printer for the first time, you're going to plug it in and you're going to want to get to work on it. Well, one of the first things that you need to do with the 3D printer is to level the bed. And the reason that you need to level the bed is if you've assembled it, there's the chance that the way that the machine works, it's not particularly accurate, and the motions of the machine aren't parallel in the front to back and side to side, the X and the Y motion system. So what we need to do is to make the bed run parallel to those axes. A lot of people call this leveling the bed. What it's actually, the technical term is tramming. So essentially, as I say, it may not actually be level per se, but it will be parallel to the X and the Y axes. And that's really important for things like the first layer bed adhesion. So I have a control system for my printers. I use Octoprint, and one of the things that I'm able to do, I've also got an auto bed leveling sensor on my 3D printers, and what that allows me to do is to probe the bed, and I can demonstrate to you guys the shape or the how in or out of level the printer actually is. So let's have a look at that. So here is a visualization of my printer. Let's zoom. Can we zoom in on this? I'm hoping we can. There we go. So we can rotate this. So this is a visual representation. I actually put this bed out of level on purpose just prior to streaming so that I can demonstrate the process of leveling the bed, or tramming the bed, if we're using the correct terminology. So the blue areas are the areas where the nozzle is low, and the red areas are where the nozzle is high. And you can see this bed is all over the place. So it is exaggerated, so you can see where the issues lie, and you can see the scale. So we've got negative 0.2. What's the other side here? Is that lower? Negative 0.6, and the highest point is positive 0.7. So we're around about 1 to 2 millimeters out from one side or another, but that can make a real big difference to your first layer. When you print your object for the first time, that first layer is super, super important. So what we're going to do is we're going to level this bed, and then we're going to set off a print because it's going to take around about an hour to print, and I don't particularly want just to sit here waiting for that. I'd like the print to be going while we're discussing. So let's get the bed leveled. One of the things I will be using is I've got a plugin that allows me to move the printer from all of the corners and the center. So I'll be using that to assist me, but ultimately, if you're setting your printer up, you're going to need to move the head around. Now, you can do this with the printer turned off, or you can use, some printers even have a bed leveling routine in them. So you can go to the menu system, bed level, and it will take you around all of the corners to level them out. So what are we going to use to level the bed? Well, it can be as complicated or as simple as you would like to make it, and I want to make this simple, so we are going to use a piece of copy paper. The cool thing about a piece of copy paper, it is about the right thickness between the tip of your 3D printing nozzle and the bed, and we can use this as a gauge. So you place this underneath the nozzle, bring the nozzle down to its 0 point, and then we'll adjust the bed adjustments to raise or lower the bed to the point where it's in good contact with the paper. It's almost like a 0-point pen rolling over a piece of paper as you drag it backwards and forwards, and you'll see that momentarily. So let's go over to the printer. So there's our printer, and I'm going to bring up my print settings on my phone because the advantage of using Octoprint means that I can access my printer over the Wi-Fi, and that you'll see later when we set the print off how useful that can be. So let's bring up, that's the printer I want. Will it take me there, or will it ask me to log in? Awesome, awesome, we are there. So I'm now on my phone. So what we're going to do is I'm going to bring the nozzle to each of the 4 corners. Now, one of the things I like to do, and this is personal preference, one of the things that I like to do is to bring my bed temperature up to printing temperatures, right? So as if I'm going to actually do a print, especially with larger printers, the heating of the bed can actually twist and move things around. So if you bring it up to its printing temperature and hold it there for a couple of minutes to let it heat soak, so that the temperature is even across the whole bed surface, we have an understanding that the bed surface is stable in terms of its temperature. So let's go ahead and go over to the printer, and I'm going to take my copy paper, and I'm going to try and do this in a way where I don't get in the way. This is going to be a little bit of a challenge, if I choose to accept it. Right, so I'm going to literally place my piece of paper on the bed, and I'm going to bring the printer over to the front left corner, And if I grab my piece of paper, it's literally jammed, right? So this is, this side of the bed is too high. So we will just adjust this little dial underneath in this corner. Each printer will have its own mechanism for adjusting the bed. And now the paper has been released. So we're going to be doing some very coarse adjustments, and we'll do this more than once in order to just get a very coarse adjustment. And the more times we do it, the closer we will get to a level or crammed bed. So I'm not trying to get it perfect the first time around. Okay. Because each time you adjust one corner, it will affect the others as we bring things into alignment. Okay, so because of how tight that has been, I'm going to do I'm going to home the printer. With a G28 command. That's a piece of G code that just says, go home. Or you can use the auto home feature on the printer's menu. Okay. So now I'm going to go through that routine again, but this time we're going to be getting a little bit closer to this being level or trammed. Okay, that's one side. It's actually not too bad. Oh, we're getting real close here. Okay, I think what I'm going to do is one round of this with the nozzle fully up to temperature. Trying not to hit this camera is a little bit of a challenge. All right. So now I'm just going to bring the nozzle up to temperature just to make sure that there isn't any filament on the end of the nozzle. If you're doing this for the first time, there probably is unlikely to be any 3D printing filament extruded at this point. But if you're doing this after a bit of usage and you're doing some maintenance, it might be worth you just bringing it up to temperature, backing the filament off, and if there's any filament that's on the end of the nozzle, it's unlikely to cause you a problem because it will literally scrape off onto the paper. So we've just set this up to printing temperatures. We're just waiting for this to come up, and we'll just do another round. Now, I did hear, you won't have heard any of the noises that are happening right now because I've got noise cancelling on my microphone, but there are some noises from the machine that I'm not particularly happy with, so I'm hoping they're going to go away in this next round, and if they don't, we'll look into what they are and diagnose it. As I say, this is going to be a bit of a supercut long live stream. If you're watching on the VOD, I will be adding markers for each of the respective points of interest, so you can navigate backwards and forwards as you need to. As always, feel free to ask any questions. Okay, we just hit our printing temperatures, so we shall go through another round. Okay, that's better. That noise I was concerned about has gone away. Okay, good stuff. Yep, we're actually quite low here. So I think there was some filament on the end of the nozzle that was not making it very practical for us. Oh, yes. Much better. And this is the most awkward one because it's right in the point where I'm going to crash with the camera. Okay, that's good. We're going to do another round of this. And we're just homing this in now. So we're going by feel. We're feeling the tension on the paper. And what I want to feel is consistent tension across all four corners. I want all four corners to be the same amount of tension on this piece of paper. Okay. I'm hoping this is the final round. And as I say, as you adjust one corner, because of you're moving it in side to side, front to back, it does impact the other corners of the machine as you raise and lower the corner you're working on. So you are going to go around this process a few times to get this just so. But once you do this, you shouldn't need to do this for a while. It's not something that you need to do all the time. If you find that your bed is going out of level on a regular basis, then you do need to look at investigating why that's happening. Okay, we're just doing the final tweaks now. That's good. Awesome. Okay, so we are now, in theory, level. Will it be perfect? No, it won't. Will it be good enough? Well, let's find out. So let's come over to the PC and let's go to our Octoprint instance. And we're going to go to the bed visualizer. That's where we were before, right? That was, pretty messed up. So we'll update the mesh now, and it's going to probe. It's going to probe the entire bed, and it's going to tell us how level or not this bed is. As long as it's reasonable, the auto bed leveling sensor will be able to compensate for a lot of this. Now, some machines, the X1 carbon and that sort of ilk, I believe the bed is screwed in and you don't adjust it. And there's a series of sensors in the machine that it will just figure out where everything is. The Prusa Mark III is very similar to this as well. The Prusa Mark III, it has it figures out where certain sensors are on the bed. It looks for certain points, and it works out if you've got the bed skewed or it's cranked, and it's incredibly clever. And that means that from a kit perspective, putting it together, your experience is a lot better. Okay, so I'm just going to, while that's updating, I'm just going to turn the nozzle off, because one of the things you don't want to do is to hold your 3D printer with the nozzle at printing temperatures for long periods of time. What this can do is it can cause your filament to carbonize and burn in the nozzle, and that causes clogs and all sorts of issues. And one thing I want to say is, if you speak to anybody who's been around 3D printing for any length of time, they will tell you they get failures. Everybody gets failures. If someone tells you they don't get failures, there's one or two things that are going on. One is that the person has been around 3D printing for a long time, knows their machine, knows their materials, and has got to a level where they can see problems in advance and can fix those things in advance. But in the early career, if you want to call it that, in 3D printing, they definitely will have had failures. The second option is they're not necessarily, they're being economical with the truth. Everybody gets failures. So if you get failures, don't get down about it. It's about understanding why something has failed, as opposed to seeing this unobtainium in the universe of the content creators where they never get a failure, and you feel less than because you're getting them. Trust me, everybody gets failures. The key to avoiding failures, first and foremost, is first layer. The first layer can make or break a print. If it doesn't go down properly, I would highly recommend that you stop the print, work out what's going on, make corrections, especially if you've got a print that is several hours in length. You don't want to get 8-9 hours into a print and find that it's failed because of the first layer. First layer, adhesion, bed adhesion. Let's talk about that while we're just updating the bed mesh. There's a couple of things that will cause things not to stick to the bed. So let me just rewind for a second. So 3D printing is, if you've ever seen somebody ice a cake, that's what's happening with 3D printing. You've got a machine that is melting the icing, if you like, and is layering up a bead of material, one on top of the other, to generate your 3D object over time. There we go. That's that leveled. So let's go to the visualizer and let's see what the visualizer has to say for us. And let's go see how good it actually is. Did I do a good job or not? Well, according to this, no. 0.25 to 0.61, 0.39 to 3.15. I'm going to print with this. I want to see what happens. I want to see how well this works out. But I will tune this a little bit. So don't forget, this is exaggerated. So there's a couple of things that will cause you to have some problems with first layer bed adhesion. The first thing is that the material you're using needs a heated bed. So if you're using PETG, if you're using ABS, those types of materials and need a heated bed, and some of them, like ABS, also need a heated chamber, so that you don't get cracking and twisting and warping and all sorts of weird sort of artifacts. PLA, you can get away with PLA being printed onto a cold bed. A heated bed is always desirable. So if you're ever in the market, if you're looking for a 3D printer, I would always recommend going down the route of having a 3D printer with a heated bed. That gives you more options further down the line. And to be brutally honest, the vast majority of printers that are new today, if you're buying a new printer or current printer, they're going to have heated beds. The way you need to look out for is if you're in the used market, you may need to just look at the specs around the machine itself. So I'm going to set off a print because I know this is going to take about an hour to print. I just need to update the settings for this. And that's where I'm going to go next. And that's talking about 3D printing filaments. Seems we so nicely talking about it right now. Let's go here. And why not show this? Why not? Why not? So I'm using Prusa Slicer. And I'm just going to say slice. And I'm going to upload that to my printer. And we are away. Okay. We're going to find out whether my leveling of the bed and my bed sensors are capable of dealing with a not so level bed. Yeah, I suppose that's one way of doing things. Go live and throw pasta at the wall. Does it stick? So, filaments. So, there are lots and lots of different types of filaments available to you, each of them having different properties. For somebody beginning, I would always recommend printing with PLA. PLA is a very forgiving material. It's relatively easy to print and to get good results, and that gives you a bit of mileage under your belt to become more confident to start looking at things which are a little bit more difficult. Technical difficulty increases when you go for other types of materials. So for example, in that scale, the next one up would probably be PETG, which is the material we're currently using. PETG is a similar material used in drinking bottles. PLA is made from cornstarch, most typically. It's polylactic acid. It's a vegetable-based plastic. The positive attributes of PLA is that the print temperatures are low, the bed temperatures are low, it's less susceptible to warping. It's not necessarily immune from it, but it is less susceptible. But there are some characteristics about PLA which can, depending upon the application of the object, can be somewhat problematic. So, for example, if you were to 3D print a cup and pour boiling water into a PLA cup, you will find that it will distort and collapse in on itself. Equally, if you print something in PLA and leave it in a hot car, say, for example, you like to make props for movies or for cosplay conventions, that sort of stuff. If you leave those in a hot car and it's made of PLA, you can find that they will distort and bend, ruining the object. So there are some filaments in the PLA range which attempt to address that, like the PLA Plus range, and they have different temperature attributes, but it's something that you need to consider what you're going to use this for. So the next one up, as I mentioned earlier, is the PETG. PETG is, as I say, a plastic similar to used in plastic bottles, and PET. The G is actually quite important. G is glycol. They put glycol into the mix of the plastic, and that assists the printing process. One step above that again would be ABS. And ABS is notoriously difficult to print on an open printer such as the CR10, the Prusa i3s. You know, you typically need a chamber, heated chamber, to print ABS. And ABS is the sorts of plastics that you find in everyday objects, the injection molded sort of things, everyday things that you have around you typically are made from ABS. So you can use it, but you have to be careful around sort of temperature control, any drafts around it that can cause warping on layer 1. It can cause all sorts of problems with cracking. So as your print gets higher and it cools, you can actually split along the layer lines. So again, if anybody has any questions or wants to delve into a specific topic in chat, feel free to interact. I'm going to be going through the process of setting up a 3D printer right the way through to completing a print. We've set a print off because it is going to take around about an hour to complete this print. And yeah, we're gonna look into all the steps from setting up the printer. We've already leveled the bed. We're now going to start talking about filaments. But here's some cool things about the filaments. We talked about the different material types and each of them having different mechanical properties, why you might want to use one versus another. But there's different properties within some of these filaments that can make a visually aesthetically pleasing print, and those are co-extruded filaments. So this is a PLA filament. It is let me see overhead. So it actually is extruded with 3 colors. So we have yellow, we have, I can see in the center here, we have red, and on the outer edge we've got blue. And when you print with this silk PLA filament, you get a very unique sort of looking object that can change its color depending upon the angle at which you're looking at it. It's pretty interesting. It's pretty cool, right? So while PLA, has its issues in terms of temperature variances and its application, but if you pick the right material for the job, you can get some pretty cool results. And that's a 3D. So this is a keyboard that I made using that filament. Alrighty, so how you store your filaments is quite important as well. When your 3D printing filament arrives, it will come with a desiccant packet inside a vacuum sealed bag. If your bag has a broken seal, beware, because all 3D printing filaments are what's called hygroscopic, meaning that they absorb moisture from the atmosphere around them. Now, what happens to those materials when they absorb the moisture is it differs. So, for example, PLA becomes very brittle. So if you take a piece of PLA filament, in fact, I might have some here that's been exposed to the air for some time. I think this grey filament is probably a prime candidate to demonstrate this. So we've got this filament, and that's perfect. That is absolutely perfect. I just tried to take this off the reel and it snapped. Right, that shouldn't do that. So let's poke that back through so it doesn't unspool itself on me. But we'll take that piece. We need to make sure we don't cause a knot in this filament, because otherwise that's going to get dragged into the machine and make a terrible mess. Let's see if we can do this without snapping it. But that was perfect. We tried to take this off the reel and it snapped in its first go, right? So this filament has become super brittle. So that's going to have a negative effect on your resulting 3D print. It could mean that, you know, parts of it will break off. So one thing you can do is to store this in its a sealable bag with a desiccant. But it's important to note that once a material like this has moisture in it, a desiccant pack will not remove that moisture from the filament. The filament has to be dried. And there are a couple of different ways that you can do this. One is to purchase a filament dryer. And essentially what that will do is you place it inside, and there is a heater and a fan, and it will heat up your filament, passing hot air over it, and the process of heating it and passing the air over it purges the moisture of the filament over time, rejuvenating it. We can recover this filament. This is not wasted. We can still use this. So, but you have to be careful when you dry the filament, the moisture out of a filament. I use a food dehydrator, which has got a temperature control on it. Now, the food, I've seen some people use like a convection oven that you would normally use to cook food in, which is doable. You can do it, but it all depends on how well the oven regulates its temperature. If the oven doesn't regulate its temperature very well, what can happen is that you can go over a particular threshold, and especially with things like PLA, you end up with a solid, like, soil, one mass of printing filaments, and you can't unreel it. It's just solid. So be very careful around how you drive the moisture out of your filaments. So that can wet filament can have an impact on first layer, in terms of it being able to stick to the bed. And when you, I've had it where I've had a wet filament, things are not sticking to the bed. I'm trying to, I didn't know it was wet at the time. I'm trying to figure out what is wrong. And we just had a print failure. That's awesome. Can anyone spot the problem? So here's a downside to a Bowden tube. Right, let me just cancel this print. The joys of being live. Okay. Okay, let's get that head out of the way so we can have a good look at this. All right, so we were doing so well, but I don't know if you noticed. We'll let this come up out of the way. In fact, yeah, that'll do. That'll do nicely. So what we see here is a drawback of a Bowden type setup, and that is that my filament has pushed the Bowden tube out. So that's less than ideal. That's not supposed to happen. And as a result, you see here that the print that I was attempting has now failed. So what we're going to do to fix this, we'll pull the filament back through. I'm going to take this little stopper off. I'm going to try and reinsert the Bowden tube. Give it a tug. Okay, that seems to have got it, but failing that, I may have a failure inside this coupling that I might need to replace that coupling. If it does it again, then we've got a problem. Okay, shall we try that again? All right. Like I say, everybody gets failures. Everybody gets failures. And it would happen to be on a live stream, right? But we're going to roll with it. Okay, that's going to set that back off. Apologies, guys. I just realized that my chat's not been updating. For some reason, my chat is not updating. That's somewhat irritating. Tom, apologies. Does Logo CD? Welcome, welcome. Cut the tube? I don't think so. Road Early Race, hey! I'm seeming to have a few technical challenges this evening, and I'm not quite sure why that is the case. That is very frustrating. There we go. There we go. I thought I'd been spending the last hour talking to myself, and you guys have just been thinking I've been ignoring you. Yeah, it's been one of those days. We think we want to cut the tube. Let me see where my scalpel is. There's probably, if it fails again, we will cut the tube, Tom. I think we'll be okay for now, but I will circle back. I will circle back. And the 3v2. Join the club. Right? That's the Jays. That's the Jays. Okay. That's the thing, right? Everybody if you've used the machine for a period of time, you know it will fail in a particular way. And you also know that when you found the way you fix it, you know how. Well, anyways, that I would never. So I was chatting away. I could see you guys in terms of the quantity of people, but I'm thinking, why is nobody talking? I'm trying to encourage you to talk, and nobody's talking. And it would appear that my window had failed, had frozen. So I refreshed it, and all the chat started coming in, thinking, "Oh my goodness!" Anywho, right? So we're back underway with the print. So let's go back to where I was. So yes, I was talking about driving the moisture out of 3D printing filament. So yes, you really don't want, certainly with PETG, don't go over 70 degrees. I think it's about 50 to 60 degrees for PLA. You don't want to go much beyond that, simply because the filament will become a solid mass and you'll have ruined your filament. So if any doubt, look to get hold of a consumer grade 3D printing filament dryer. And they'll have programs for PLA, PETG, ABS, and the like. One of the most hygroscopic materials that you can probably get will be nylon, but not printing nylon is probably like intermediate to advanced, if not advanced level sort of printing, right? So a little bit out of scope for what I want to talk about today. Well, okay, so I use Prusa Slicer. So let me just rewind a second. So your 3D printer talks in a language known as G-code. G-code is essentially a series of movement instructions: X, Y, Z, go here, do a circle, do a line, etc., right? So when you get a 3D model, you have to translate an object into the G-code that the 3D printer understands. That piece of software is called a slicer. The slicer takes that 3D object, it breaks it down into individual layers, and it figures out the movement instructions that a 3D printer needs to replicate in order to create that 3D model that it's currently looking at. And there are loads of different types of slicing software. Ambu Labs has got their own, Creality have got their own, but for the vast, I could be erring on the sides of being controversial, but the vast majority of them will, they're open source as such. It's a standard sort of G code. It's not proprietary code. If I was to looking at a 3D printer today, I probably, unless the features of the machine like blow my socks off, I would be looking for something that I can talk to with standard G code. I do not want to be software linked into a printer because I have to use proprietary software. So, indeed, Rally Race. Indeed, that is definitely for another time. Okie dokes. So we are okay. So we have a failure. We are not moving forward in the conversation because we have a failure on the Bowden tube again. So it's either the tube has been damaged, or we have a failure of the fitting. So let's cancel the print. Cancel the print. I'm going to go to the temperature settings. I am going to hold the bed at printing temperature, and I'm going to hold the PETG at printing. And now what we're going to do is we're going to we're going to back out the filament for sure. And then we're going to see what we can do about this tube. In fact, I'm going to lift the head up by a little bit too, because otherwise it's sitting over the plastic, just burning. That's just asking for clogs. Let's go 100 millimeters. So Tom, I think I'm going to go with your recommendation to cut the tube. But first of all, we've got to back out our filament. I'm going to just do that by pulling it out of the tube. So you can see that it's been cut up with by the fitting, and I think it's just lost its ability to grip. So let's get the scalpel. So you're still not decided to get the K2 yet, Road Rally Race? What's it going to take? What's it going to take to push you over the threshold to make that purchase? All right, let's see here. How can I do this where I'm not going to cut myself? I'm going to pop it down onto here, and I'm going to use a scalpel to cut this, and I'm incredibly khaki-handed. I'm now going to cut it with the wrong hand, so I'm going to try and cut this as straight as I can. Okay. Let's back the filament off. Now, if this fails again, what this is going to tell me is that the teeth inside of the fitting, they have lost their ability to grip the tube. They've become worn, damaged, etc. over time and usage, and therefore they'll need to be it'll need to be replaced. So let's pop this back in, push it all the way into engagement. Oh yeah, that fitting has failed. Of course it's failed. Right. Let's see if I've got any spares. Hoping I've got a spare fitting, because if I don't, this could be I could be cannibalizing another printer to get its fitting. I've got a couple of machines down for maintenance. Just checking all of the available boxes here for... I've got one more place to look. I think I might have a fitting. I'm just away from chat right now, so I can't see what you guys are typing. But yeah, let's go have a hunt. I'm going into the depth. Right, what am I looking for? Okay. Well, that is less than ideal. All right, so for the purposes of this live stream, what we're going to do is we are going to cannibalize another machine for its fitting, just to... I mean, it's got to have maintenance anyway, right? So it's not a biggie, but it's not what I like to do. Okay. So I have a fitting. It's whether or not I can remove this with my fingers, or whether or not I got... Oh, I got a pair of pliers. What's up? What are we saying? Okay, so this fitting, we're going to look at it and see how it's failed. But yeah, this is the joys of 3D printing. This is a constant... It is a constant sort of battle of the wits. Okay. Let's just nip that up so it's not going to undo itself. Doesn't have to be mega tight, but tight enough so it doesn't work itself loose. Push this in. We should. Oh. Gotcha. Okay, retaining clip. Perfect. You shall not defeat me. All right. Let's clear up this goop. And we will go once more into print mode, shall we? Let's pick up our gauze, put them away. All right. You think you can 3D print the fit in? Well, I'm hoping it's fixed. I'm hoping. Okay. Let's set that print off. And fingers crossed, we shouldn't see filament being pushed out of places it's not supposed to come out of. That's exactly what's happening. That's exactly what's happening. Alrighty. So, where was I before I got so rudely interrupted? Yes. So, damp filaments can cause all sorts of problems with first layer adhesion. And that can be the difference between a print failure and a success is that your filament is wet. So one sign of a wet filament is things not sticking to the bed properly. Secondly, stringing. If you get stringing, certainly with PETG, stringing is a sign that we've got a problem with moisture potentially. There's lots of things that cause stringing with PETG, but in my experience, when I've got a good dry filament, stringing is not an issue. The retaining hooks. Yes. No, I have the retaining hooks. It wasn't a retaining hook issue. So, but yeah, I'll probably look to order up some new fittings now. It would seem that the ones on my machines are becoming end of life. But that's for another day, right? Maintenance. So that's about set off on its merry way. So, what are the other things that can influence print quality, things sticking to the bed, all of that sort of good stuff? And that is printing temperature. It's a very, in my view, very overlooked topic, which is, what temperature do you print your material at? Now, on the side of a spool of filament, in fact, we'll take this PLA filament as an example. So tricolor silk PLA, 1.75 millimeters. That's the diameter. The vast majority of filaments is 1.75. There was another. You could get 3 millimeter filament, but that's not so common these days. but 1.75, and it's got some details about the print. And it's got a section here for, come on camera, print temperature, 190 to 220. I would say look at these print temperatures as a suggestion, as a guide. There's a number of reasons why this printing temperature is going to be out. And the reason for that are numerous. So let's look at the 3D printer itself. So first and foremost, you've got manufacturing tolerances. The temperature sensors in your printer are manufactured one after the other on a production line. So there's going to be variances from one to the next. And yes, there's quality control, but the question is how good is that quality control? How consistently are the devices? If you had two of these devices side by side, would they measure the same temperature? And the reality is that there is some variance from not only from sensor to sensor, but from manufacturer to manufacturer. So you've got Prusa, you've got Creality, you've got Bamboo, you've got Ultimaker, right? You've got all these different brands, and the chances are that the temperature variance, the temperature measurements between printer to printer can be different. The second thing that you need to think about is around the environment that the printer is actually in. So I'm in the UK. I've got a somewhat damp environment, and you can't look at that the same way as somebody, let's say, for example, in California, in a very arid sort of environment. So one of the things that you probably want to print to find out what print temperature should you be printing at is a temperature tower, right? A temperature tower is a useful 3D print because it tells you through a range of temperatures, wrong one. It tells you through a range of temperatures how your printer is performing. So a temperature tower typically has a series of features such as undercuts, overhangs, bridging. It has all the sort of complexity of like things that you're actually going to print, like an object, but you can observe, what temperature does to each section. And the idea of a temperature tower is each segment is printed at a different temperature, starting with the hottest to the coolest. And you can just visually look to see which one of these looks to be the best. When you find the visual side of things that it's about the best, you then look for strength. Try and break this print to see where the layer adhesion fails. So this is where we did that on this print. We broke it. So we started at, the coolest is 220, and it's increments of 5. So that's 220, 225, 230. So 240, 235, 240 is where it's at in terms of print temperature. So that's something that I use to identify the correct temperature to be printing at. And ideally, you need to be doing this for each brand and each color of filament. So a Arian red PETG will be at a different print temperature to a clear or to a blue, right? So always when you use a new filament, until you understand it, before you print anything, print one of these per reel, and then you can figure out which temperature your machine likes to be printed at, and it includes the speed as well. Let me just quickly catch up on chat. You would have slapped my hand if I touched your print bed like that. See? PEI plates stick. Great. Yeah, they do. The problem with PEI and PETG is that if you don't get the nozzle height just perfect, let's say you're too close to the PEI sheet, you can actually bond PETG to that sheet to the point where you're tearing that sheet to pieces to get your print off. So they are a little bit of a double-edged sword in my mind. Still don't want to touch it with bare hands. Yeah, I mean, finger grease. If you have a particular problem with things not sticking to the bed, finger grease can be a real issue. So things like cleaning the bed regularly with isopropyl alcohol. Back in the day when I used to print ABS exclusively, one of the things that I used to do was to make a coating, an ABS slurry, where I would use acetone. I would melt ABS into acetone because it dissolves in acetone, and then that resulting acetone ABS goo I would spread on the bed in a fine coating to create like this material that would bond prints, and it worked amazingly, to be fair. But we'll come on to that. Orca Slicer has a... Do you know what? That's something that I haven't tried just yet. I've heard some really good things about Orca Slicer. What's your guys' opinion of Orca Slicer if you've used it? I know it is I don't want to say it's a clone. I don't want to say it's a fork, but it's a slicer that is compatible with bamboo printers, or at least was up until recently. What's your opinion? What's your opinion of Orca Slicer? Is that something I could be looking into? Because, like I say, I exclusively use Prusa Slicer. I've used that for some time because it got rid of a lot of problems I used to have with Cura, the Ultimaker Cura slicer. So I'm really interested. I'm really interested to know what your feedback is. You clean the bed every print with some soapy water, clean and heat it up. So I don't clean the beds that frequently. One of the things that I do use, and I absolutely love, is Magigoo. And this is, I bought one bottle of Magigoo. I've got 3 CR10s, 2v2s, 1v1. And I've used this. I'm down to the last quarter of the bottle. If you go into my YouTube videos, you'll find that I made a video about Magigoo. This is that bottle. This is how long it has lasted me. And it has dealt with all of my bed adhesion issues. This is like the magic bullet that finally nailed everything. You should be able to print on clean glass, which I have done. But yeah, I had a spate where the variables were all over the place, and Magigoo has pretty much nailed that. I'm not sponsored by Magigoo. I wish I had a channel sponsor, but I'm behind Magigoo. I really like the product, and it's done wonders. And I print predominantly, well, almost exclusively, with the couple of rare exceptions of printing in PLA. I predominantly print in PETG. So anyway, catching up. I use Orca Slicer but need the code that stops it coming out of the bed check like Cura when it's... What's that in relation to, Tom? I'm not quite sure what that is. I use Orca Slicer, but I need the code that stops it coming out on the bed check like Cura with its code. Not quite sure what that's referencing. I need a little bit of context on this comment. So it works really well, and the supports are brilliant. Yeah, I'm going to spin it up and give it a try. I might do a video on that and see whether or not, from a non-bamboo user, from a legacy. I mean, my printers are circa like year 2000, right? So year 2000, 2020. Dear God, my brain. So the two CRT MV2s I got through lockdown, and I did a lot of PPE. I printed frames through COVID, etc. So yeah, that's where these printers are from. So they're 5 years. This 5 years old. They've done quite a bit of printing, minimal maintenance. To be fair, the only modification that I've made to them is I've added the auto bed leveling sensors, and those were from Creality. So that was part of the firmware update, etc. So yeah, I have eyes on building a boron. So it's nice to tune in, makes all the calibrations automatically. That would be cool. Yeah. Definitely. I'm definitely going to give it a go. Anything that makes my life easier, in terms of printing, I will give it a go. So yes, it sounds like in chat we've got a bunch of people here who are familiar with 3D printing. So from those of you who are watching who are new, we're talking about slicing software, which a slicer, what it does, let me demonstrate, right? What it does is it takes a 3D object. The object that we're printing is the 3D Benchy, the ubiquitous little code that we all print to test our printers to see whether or not our printers are working the way we want them to. So here's that in Slicer, in Prusa Slicer specifically. So what happens is when we slice the file, it turns that into these layers, and these layers are how the object gets made on the 3D printer. And there's a couple of determining factors into how the thickness of the layer, how thick is the layer, etc., etc. And that's partly to do with the nozzle diameter. So most printers come with a 0.4 millimeter nozzle. That's a standard size across the vast majority of printers. You can go smaller, you can go bigger. So the nozzle determines how the maximum height that you can go. So the recommendation is around about 80% of a nozzle diameter is the maximum height that you really want to go. Beyond that, you'll start to get weakness in the strength of each of the layers because it doesn't squish the plastic properly. So for a 0.6 millimeter nozzle, which we're currently using, the maximum, I believe, is it 0.42? I think it's 0.42, or is it 0.46? It's somewhere in that region. 0.36 is the maximum layer height for a 0.4 millimeter diameter. So when you change the nozzle diameter, you can print thicker. When you print thicker, you print quicker, but there is a trade-off. The trade-off is you lose resolution, you lose detail in the Z height. As you see here, the text in the back of this boat looks really, really unreadable, right? But if I changed it to, I don't know, 0.1, and then we've sliced it, figuring it out, you see the text is now a lot more readable. So the coarser the heights are, the quicker you're going to print, but the trade-off is you lose detail. Okay, so let's have a look. When I used Cura, there was a code that stopped the print leaking out. The print leaking out? What do you mean by that? Are you referring to oozing? If you're referring to oozing, are you thinking things like retracts and nozzle wipes? So yes, the software. The software that we use to convert from a 3D model to a 3D print, that is a slicer. And there's lots of different ones. We've just been discussing Orca. No, Tom, apology is not needed, right? It's the wonderful world of live streaming, because there is a delay between the text that you type and I see it to me being able to respond. So yeah. So yeah, you're probably looking at retracts, and you're probably looking at nozzle wiping. Yeah, retracts and nozzle wipes. They're usually so nozzle wiping, nozzle posting. These are all things that you can implement or tune to get a better result. So it stops. So for example, when you get to a corner, it will stop pushing the filament, and that may even actively pull the filament back slightly as it changes direction. So it wipes the nozzle across the corner, so you don't get a bulge in the corner. So so yeah, the settings that you're going to be looking for is retract. You're going to be looking at nozzle wiping and juicing. Those are the terms you're probably going to be looking for in your respective slices to stop oozing. Now, if you're at printing temperature and you find that filament is oozing out of the nozzle, then you'll probably find that your filament is wet. Especially, and you listen out for like a popping, hissing sort of sound, because your nozzle is running at 200 degrees plus. Water boils at 100 degrees. Any moisture in that filament is going to cause it to ooze, pop. You'll notice that surface finish also is impacted. So you'll get some like a matte texture to a filament wall when you're printing, when it's wet, and when you get a dry filament, it's like sharp, pristine, it's glossy, you know, you get it looks nice, right? You can definitely tell. You can definitely tell when you've got a wet filament on that. Let's have a look. So you've got the same as me. You don't use Clipper. Clipper is something I'm interested in getting to understand. I think am I correct in thinking Clipper is a hybrid between a core firmware on a printer and Octoprint? It's kind of like it's got a Raspberry Pi and the firmware, and they work together to symbiotically create the firmware. And it can do some really cool stuff. I think the Voron uses Clipper, if I'm not mistaken. Now, I do have a Voron build, scratch build, in my future. I could very well be converting all of my estate of printers over to Vorons. That I've got to get some money behind me to commit to that. I'm not there yet, but we'll see. And I'll definitely make a video about it. So if there's anyone watching who wants to support that video, you know, hit me up. Cool. Okay. So, as I was saying, the temperature tower, the humble temperature tower, is a really useful tool in determining what temperature you should be printing your filament at. It's a very simple print, and let me show you how that. People in chat have already mentioned that Orca Slicer has this feature already built in, but in Prusa Slicer, it is a bit of a manual process. So let me go ahead and open up recent projects. Here we go. can discard all of this. So here is my temperature tower. This one is specifically for PETG. And if you go onto various different libraries, you'll be able to find temperature towers that you can use to calibrate your filaments. The only thing I will recommend is that whichever temperature tower that you get one that's got a solid base. I've seen ones out there that have got like this little section at the bottom missing, and it's two columns. And the problem with that is that if you have any bed adhesion problems, the tower is going to fall over. It will fail. You will not be able to calibrate your filament. So the more surface area that you've got in contact with the bed, you are more likely to get a success out of that. So you'll see that the filament or the model has a temperature starting at 260, and each segment decreases in temperature by 5 degrees. So in order to print this, one of the first things that I'll do is come into my filaments, and I will change the temperature to the maximum for the filament, just here, to 260. And then I will go ahead and slice the file. And once I've sliced the file, I'll drag this vertical slider bar, and I will find the intersection between segments. And then what I will do is I will right-click this here and choose Custom G-Code. And in doing so, what I can do is add, can I open this window? Oh, no, I can't. Add just Custom G-Code. I add the M104S command. So M104 says set the nozzle temperature. The S is the value that you want to add. So this would, in this instance, this would be 255. Okay, and then you click on OK, and you work through the model to each layer transition, and you add each of these temperature changes so that as you move into that, it prints at that temperature. Now, it's really important that you keep in mind that the relationship between the speed the printer is moving, the nozzle diameter, and the filament are all things that contribute to this temp tower. So if you want to print faster, I would print a temp tower at that speed. If you want to print thicker layers, print at that thickness. And especially the thicker you get, your ability for the filament to pass through the nozzle, you may need to adjust the temperature up to compensate for the higher throughput of filament. Okay, let's quickly catch up on chat. Pi process, the firmware used as the interface. Right, gotcha. G91. I'd have to look that code up. Is that G91 is that the code to try to use the mesh? Relative positioning. Okay, cool. G1 is move. Is G Okay, you should have me back. Hopefully that should be on point. Okay. Yeah, guilty is charged. Unlike my Rogue mic. I recently did a battery change on my receiver, so I'm wondering whether or not I need to do a battery change on the on the transmitter. But anyway, we're back. We're back. I'm plugged in. We're charging, so we should hopefully be back up and running pretty quickly. In fact, talking of which, I think I need to plug in this camera before that fails. That would be really good. I'm a pro live streamer, right? Who'd have thunk it? Okay, so the print is working pretty well. The road hit the road. I see what you did there. I see what you did there. Hey, Dimitri, welcome in. So we're a little ways into printing our little benchy, and we're going to see whether or not that print has turned out nicely. So, yes, we were talking about the temperature tower, and that ultimately informs us what printing temperature we should be using for a given filament. And be careful, right? Because just because you're printing PETG doesn't mean to say this clear PETG doesn't mean to say you're going to have the same printing temperatures when you print in red, in blue, in green. So you do need to keep that in mind. I would recommend that even when you're getting filaments from the same brand, if you're getting different colors, run a temp tower, even if it's between machines, until you understand how your machines are behaving. I would recommend you print a temp tower between machines and with specific filaments, right? So that you know that on printer 3, this blue PETG prints at 245, but on the other printer it prints at 240 or even 235. Da, 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 da. I've not used Orca. So I have Prusa Slicer. And yes, I still have Prusa Slicer still open. So one of the things that I absolutely love about my setup is two things. One is that I've got Octoprint running on a server. I've got 3 instances of Octoprint on a server, and that means that all 3 of my CR10s are wireless. And the second thing that I like about my setup is that I can control my printers by voice, specifically to turn them on. I can't tell it, hey, printer, print this object. Let me give you a demo. So this is the 3rd printer in my series. And RIP camera. Ah! That's why I need dedicated setups for these cameras. I can turn these printers on, right? Here we go. So I can say, Ziggy, turn printer 3 on. So that's really handy for being able, I can turn the printers on remotely as well and send prints. So those two features, voice activation and Octoprint. Octoprint is a game changer in my view for any printer that's not natively wireless. I no longer use SD cards to transfer my prints from one location to another. That's a done deal. So, Ziggy, turn printer 3 off. So that's what I've got in my toolkit, and that's not the power on feature. That is not something native to the Creality printers. That's something that I've set up. I've stripped the control box down and I've installed some bits and pieces in there. So let's have a look, quickly catch up. Oh, Orca's a branch of Prusa Slicer? Is it really? Is it really? Okay, that's interesting. So we're looking at some G code here. So this is a custom G code that you were inserting at the end of a print, right? If max layer underscore Z is less than printable height G1 Z. Oh, right. Okay. So this tells you to move out the way, right, and lift the head. I think the Prusa Slicer has that by default. Let me just quickly check my printer setup. Yeah. So if I come here, right. So if I come into Prusa Slicer and go to printers and then custom G code, you've got this section down here at the bottom. Yeah, it's pretty advanced, right? So we're going to talk about setting up our first 3D print. So we've talked about the printer setup. We've talked about slicing software. We've talked about leveling the bed. We've talked about filament, and we've talked about filament maintenance in terms of keeping them dry, temperature tower for calibration, all of that cool stuff. Now we want to get into the business end of things. So we want to actually print something. So the first thing you need to do is to get a file, right? You need something to print. So where do you get your 3D printing files from? Well, there's ultimately two main places that you get your 3D printing files from. First, the first place you go, especially as somebody coming in new to 3D printing, you're going to get your files from a library. So these libraries, there's a couple of different categories of libraries. One which is a free library and one which is paid. That's the first distinction to make. So you can go to your favorite search engine and type in 3D printing files library, right? Or 3D printing files. And you're more than likely going to turn up a bunch of websites. Let me pop this out and bring this down here. So you can go to the daddy of all libraries, free libraries, that is. And that is Thingiverse. So Thingiverse has been kicking around ever since I've been printing. So it's in excess of 10 years that Thingiverse has been around. And what you see here is all the files people have uploaded, and there's lots of different things, right? From some tools, like, this is the main page, right? Showcasing what's available. You've got a funnel. You've got a filament filter, which wipes your filament. You've got some airsoft stuff or even cosplay stuff. Definitely cosplay stuff in the Daredevil helmet, right? So there's a bunch of things that you can look at in here and download. So let's search in here for, I don't know, let me see. I probably spelled it wrong. Let's search for Pokemon. Right, so you got Pokemon. You got a Pokemon chess set. You got Pokemon characters. So one thing that you need to really pay attention to in these libraries are the rules around usage. So under the thing details, if we scroll down here, you'll see a section for license, right? It's saying that who is it by? It's licensed under Creative Commons Attribution, non-commercial, no derivatives. So if you use it, you have to give credit. You're not allowed to use it for business. You're not allowed to print it and sell it. And you're not allowed to take the model and modify it and create your own version of it. So you need to pay attention to the license. There's lots of unscrupulous people on the internet who will go and get these files, print them out, and just sell them on eBay, Etsy, and all these sorts of places. And regardless of whether you get caught out or not, it's unethical and it's harmful to the community of 3D printer designers. So you really do need to follow the licenses. I would highly recommend it. Notwithstanding any sort of legal implications, it's just not cool to take someone's stuff and just profit off it, right? Yeah, exactly, Tom. It's super not cool, right? Somebody's taken the time to model these objects and made them available to you for free. So if you're intending on selling these things, printing and selling them, I would suggest you do one of two things. The first thing you do is you create your own. So you learn a CAD program of some kind and you model your own object. Therefore, you own the sort of license around that. Notwithstanding intellectual property of, you might, if you make something from a Disney movie and, start selling it, they might knock your door and tell you to stop, and they might have lawyers get involved and things like that, right? So that element of it put to one side for someone's IP. First things first, don't print other people's stuff, right? Second thing is you could try, if you don't have the skills in CAD, what I would recommend is reaching out to the creator and seek permission. And this will go one of two ways. They're either going to say no, or they'll say, I'll license you. You need to pay me X amount per sale, or some financial remuneration that they want for you to have permission to be able to print and sell. And if you do that, make sure you get evidence, like in an email, to say that you've got permission. So if anyone comes back to you, you've got you've got effectively permission from the author of the files. So you use FreeCAD. Yeah, I mean, so I did a video on FreeCAD. I've used multiple different CAD programs. So to create your own files, you need to have you need a computer aided design software, or CAD for short. There's loads of different types of CAD out there, and these CAD programs have been created with a purpose in mind, typically. So you've got the likes of FreeCAD, Fusion 360, Rhino, SolidWorks, SketchUp. There's a bunch. The first CAD program, believe it or not, that I used was OpenSCAD. Talk about finding the most complicated ways to do the simplest of things. FreeCAD is a parametric modeler, meaning that you can set variables. It is a code-driven CAD process, like Fusion 360, like FreeCAD. You can go in and change variables in a timeline, and it will recalculate and create the 3D model based upon that. But imagine trying to design a 3D object with Notepad, a text editor. That's OpenSCAD, and that's the first. That's my first entry. So talking about Frank and the flat end bracket and the first extruder that I designed, I did all of that in OpenSCAD. Yeah, and I'm not a coder either. So it was a trial by fire, to say the least. So applications. So I've got a few videos on the channel about using FreeCAD for the first time. I like FreeCAD's ethos in that it is an open source CAM program. So CAM is for computer aided manufacturing. So it can drive a CNC machine and all of that sort of cool stuff, right? My bugbear with FreeCAD is the user interface, and I suppose I can't be too mean on the FreeCAD project because it's open source. It is being developed by people who are enthusiasts. They're not being paid to make the software, so you cannot compare FreeCAD. You can't compare FreeCAD's UI on a level playing field with something like Fusion 360, because Fusion 360 is a multi-million organization, right? And they have funds and resources to be able to make a user interface which is user-friendly, has a shallow learning curve. You know, all of the things that reduce the friction from a user to be able to create things. You know, it is my preferred software. I'll be brutally honest. And, you know, I did the FreeCAD video when they did the license shakeup, because that created a massive stir in the community, the maker community, because of the changes that they made. And I'm not necessarily so much angry at the changes that they made, because at the end of the day, Autodesk are a company. A company needs money. And making money isn't a dirty word. The fact that that an industry grade CAD application has a free tier that you can use is impressive in its own right, because I don't see anyone else doing that to the level that Autodesk do. And it could be like, you know, get you high on their supply type of, you know, get you hooked and then get you paid, right? Get you paying. But from a maker's perspective, it's opened up the tool chains. Yeah, I learned Fusion 360 predominantly because it drove 3D printing, CNC and laser cutting. I didn't have those at the time that I started using it, but I knew I was going in that direction, and I didn't want to learn one program per discipline. I wanted one program, and Fusion was that for me. Now, if you guys can use OpenSCAD, if you guys can use FreeCAD, if you can, use Notepad, if it works for you and it gets you the results, kudos to you. I am not going to try to persuade you any different, because what works for you may not work for me. Do you understand what I'm saying? So Tinkercad, yeah, that's another one. Bob, I need to revisit FreeCAD. Now version 1 is out there. There was a version of, or a fork of FreeCAD that was more akin to a commercial product, and I know that project failed. I forget what it was called, but I wonder how much of that has been ported back into FreeCAD version 1. I'd be very interested to see what that looks like, and the challenges of the user interface in pre-V1, have they been rectified? So yeah, Tom, I'm in a similar camp. The workflow. Have any of you used Blender 3D? I dabbled with Blender on and off since the early 2000s, and Blender is more of an artistic CAD program, the sort of thing you would do special effects for a movie in, like Maya, those sorts of things. The user interface in Blender, when I went to use Blender, was so backwards. It was insane. It broke my brain. I guess to some extent that's potentially a positive and a negative. It's a negative in the sense that it's a learning curve to getting into it. But secondly, it challenges the way you think about things, which is not necessarily a bad thing. But Blender, have a look at blender.org and have a look at their open movie projects. If you've seen Sintel, Big Buck Bunny, these are all short movies that have been created by Blender. Blender was founded by a guy from Amsterdam. I'm not sure if he's France, but he's from the Netherlands. A guy by the name of Tom Rosendahl. He was one of the founding members of the Neo Geo game console, right? And when I first started playing around with Blender, it was somewhere in the region of 25 megabyte download. And it had fluid simulation, smoke simulation. It had all sorts of cool stuff in it. And it was like tiny. You can use Blender for 3D printing, but it's kind of like every tool's a hammer sort of mentality. But yeah, if you're interested in Blender, if you're interested in like the artistic side of things, like rigging characters, motion capture, it's got those features. The Spider-Man series, not the first set. So there's three sort of reboots of Spider-Man. The second reboot, the Spider-Man 2, I believe all of the previs work for that movie was completed using Blender 3D. So that's the sort of software we're talking about, right? It is complex, yes. As is Fusion 360, I will say. So Fusion 360 has a bunch of workbenches. So you've got the mesh, you've got the solid, you've got sheet metal, you've got manufacturing, you've got simulation, you've got electronics. There's a ton. There's a ton under the hood of Fusion 360. The only thing that I am not currently using Fusion 360 for is my electronics workflow. And the reason for that is because I want to sell the electronics that I make. And under a personal license, I got to double check this, so I may be incorrect. I may be wrong about this, but I believe the maximum you can earn with Fusion 360 is around about $1,000. Oh, that camera needs a reboot. Give me 1 second. The print is just finished. Okay, let's see if I can refresh this camera. Come on, camera. You know you want to. You really do want to. Okay, let me see if I can just kick this camera into working. Give me 1 moment, please. Nope. That camera needs a reboot, and we're not doing that. Okay. We'll take this off. That's well stuck. So here is my 3D benchy. So I just come from top down. So here is the 3D benchy, and the 3D benchy is a really good print to use for like the first print. The reason for this is there are lots of features that the benchy has that in fact, I'm gonna bring back to this camera because I'm pretty sure we're gonna get a better view of this here, right? So there's a lot of features. So we've got steep overhang, right here at the front. We've got unsupported archways. We've got embossed or debossed portholes here for like that anchor, right? So there's lots of geometry in here. There's like an unsupported overhang in the stack. And just by printing this out, you can have a look to see whether or not your 3D print has any issues, and you can kind of troubleshoot what's going on. And that's the whole purpose of this model. That's the whole purpose of the benchy. It is a calibration test to tell you how well the printer is working. Now, everything is looking good apart from one thing. There is I don't know if you guys are picking this up at all, but let me see if I can show it. Get real close here. There is a small amount of stringing. You see that? Just there? In the archway, in the doorway? So this tells me that this print has got one or two things wrong with it. This is PETG. This is a clear PETG filament. So there's two possible causes, or three possible causes that could be causing that stringing, because PETG loves to string. Oh my gosh, it's crazy, right? So the first thing is tuning your printer, so your retraction, your wiping of the nozzle, etc. And I'm personally 90 to 95% confident that the machine is tuned. So that leaves two other variables. One of them is temperature. So maybe I was printing slightly too hot. I need to dial the temperature back just ever so slightly. And in all fairness, I did increase the temperature from what I was printing with previously, because we had that blowout on the Bowden tube, and I was trying to reduce the force needed to push the filament through, just so while on the live stream we got a successful print. So there's a chance that I'm running the temperature a little bit too high. Probably be about 10 degrees, 5 to 10 degrees too high. The other thing that could be causing this is there is moisture in the filament. And in all fairness, this filament's either been up on the rack behind me or it's been on the printer, and it hasn't been stored with keeping it dry in mind. Now, I have in mind that it is a temperature thing, and I'll explain why I think that. See if I can show this on camera. This is going to be a bit of a challenge. What I want you to pay attention to is this sidewall, and specifically the colors, right? So you'll notice as the light catches the print, there is this really shiny segment here, right? And down here, it's not so shiny. So what is it about this feature? You can also see it's gone really translucent, right? Whereas this is more frosted. So what's going on here? Well, my theory is this. I think the temperature is too high because down in this segment here, we've got all of the infill, and we've got a lot more of, there's a lot more geometry that needs to be, come on, camera, focus. You've got one job, right? So you've got the geometry, like infill, the walls. You've got a lot of material like being printed here. Up in this section of the boat, in fact, I'm going to go over to the other camera because you guys definitely cannot see this. I'm going to zoom right in. So here we go. Here we go. I'm going to hold it up. Right. So this section right here, with this section right here, the travel time to print this section all the way around the front, back, etc., is shorter than, let's say, down here when I've got all of this geometry in the boat to print as well, right? So this bit here is going to print way quicker than the section down here. And in doing so, it's highlighted the fact that this material is going clear because it's printing hotter. The layer hasn't cooled down before the next layer is being applied. So I think we're slightly too hot, which inadvertently has caused the stringing in the doorway. See if I can you guys see? You can just make out that stringing. Just get my fingers out of the way. Let's get you close. Ah, that's a little bit better. You can just make out the string there, right in the archway. So I think it's more likely rather than the filament being wet, I think the filament is being printed at a too hot a temperature. Okay. So with that being said, let's go into a quick fire question round. Does anybody have any questions? What questions have you got for me? And while we're waiting for that, let me just jump into Prusa Slicer, and I'm going to show you how I print using Prusa Slicer. So I'm going to delete this file, get that out of here. I'm going to select my model, and let's choose the Benchy. Okay. I'm going to go into my filament, and I'm going to set the temperature that I want my filament to be printing at. So 235. 235, like so. And then let's go here. And then over here in this panel on the right, I start to select certain things, right? So the first thing I'm interested in is what is the thickness of the layer height that I want to use for this print. Now, for this, I actually printed 0.36 chunky because that means it printed quicker. If I go chunky, and then let's go discard that and slice. Over in the left-hand side, we're going to get an estimation of how quick this print is going to take. So the total time here, just above me, is 52 minutes. The first layer is going to take around 2 minutes. And then this chart here breaks down where that time is being consumed. So if you wanted to try and speed a print up, you can look at, okay, what is it about this print that's eating my time? So here it's external perimeters is taking 14 minutes of that 52, right? Is there a way we can improve that? All right, could we speed the printer up? Blah, 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 right? So it gives you a bit of insight in how you can tweak the settings. Whereas if I go to, let's say, a 0.1 millimeter layer height, so 52 minutes, remember? If I go to 0.1, we're going to exponentially almost quadruple the number of layers. So what's going to happen is going to take longer. So rather than an hour, it's going to take 2 hours and 47 minutes to print. But you look at the level of detail that this benchy would have, the steps, they're a lot finer, certainly in the roof. They're not as coarse. So just by adjusting your layer thickness, you can, let's go somewhere in the middle. Let's go for, say, 2.4 as a draft. We'll slice that now. So 52 minutes is the shortest. 2 hours 47 is the other. And with 0.24, we're now looking at 1 hour 12 minutes. Right? So the layer height is directly proportional to the speed of the print. The only one thing that I want to talk about before we delve into any questions that you guys might have, and that is infill. So infill is essentially, there we go, is this sort of geometry, this crisscross pattern in the center. And you essentially want to dabble with the amount of infill that your 3D prints use. So if I was to print with 100% infill, let's go into my printer settings and to the infill. We're currently set to 15%. If I say 100%, right, and we slice, switch to rectilinear, slice now, you'll see every single layer is completely solid. Now, the amount of filament that you're going to use is down here in the bottom right. Used filament in grams is 20 grams. You're using 6.58 meters worth of filament in this model. I think that's an incredible waste of material. So typically you can reduce that. So you could come down to, let's go the other extreme. Let's go to 5%. And we'll go to, we'll keep it rectilinear for a second. Let's slice now. So we get different shapes of infill. Now look at that. So you've got really big gaps between your objects now, right? And if I come to the top layer, you'll see how the top layer is not being supported. If you have if your infill is too low, you can get what's called pillowing. And that's where it's really odd. Where the material isn't supported, it actually bows up. It puffs up. You'd expect it to sag, but it actually puffs up. And pillowing is an artifact of the infill being too low. Now, infill is not, I don't want to say it's zero influence, but it has a low influence on the part strength. Okay, so you want to set your infill value to something where it's a happy medium, where you're getting good support, you're not getting pillowing, and let's go to about, where were we? We were at 15%. We'll slice that again. There we go. So we get a decent amount of support now for our solid layers. We're unlikely to get pillowing. One way you could get away from pillowing is by adding more top layers. So typically the default's around 2 to 3 layers. You could add another 1 or 2 layers on top of that, and that would help reduce pillowing. It wouldn't necessarily get rid of it completely, but you take the point. And the actual strength of a 3D print comes from the walls, of all things. So with a 0.4 millimeter nozzle, I would typically do 3 perimeters. So in your slicing settings, if you come to layers and perimeters, this vertical shell section just here is set to 2. That is the typical default. But if I bump this up to, say, 3 or 4, and we slice again, you'll now see these walls are 4 layers wide. So the more layers wide, the stronger your model is going to be. Now, with a 0.6 millimeter nozzle, I typically don't go to 3 or 4 perimeters. I stick at 2 because the added thickness of the nozzle is ultimately good enough at this point, right? So we'll go back there and we'll reslice. So it's 1.2 millimeters thick already. So that's a good thing. So final call on any questions before we look to wrap things up. Again, if you're watching on the VOD, feel free to comment below. I'll come back round and try and answer any questions that are left behind. But if we're looking like we've covered everything, I think this is probably a good place to conclude our evening. So until next time, have fun, be safe, happy printing, and I hope this video live stream has answered a bunch of questions, but I'll happily do a follow-up video if necessary, if there's a topic that we need to cover. So until next time, have fun, be safe. I will catch you in the next one. Bye for now.